Hello everyone, my name is Wicitra Anak Perempuan Segarang and my metric number is 198839. So, today I'm going to explain what I understand about the inspection method. So, in this inspection method, there are four methods to find the particular solution, which is YP. Here is the general form of the non-homogeneous equation. So let me go through the four methods on how to find the YP. So here the first method is when the arc x is equal to arc naught where is constant and the an here is not equal to 0. So we can inspect the YP equal to arc naught over by an. And then the second one is where the arc x also equal to arc naught, but now an is equal to 0. So it will be this form of homogeneous equation where the dk is lowest order derivative of y. And then we can inspect the YP by using the formula arc naught times with x power of k over k factorial, and this one is the constant of the lowest order derivative. And then the third one is where we have more than one arc x. So when we have more than one arc x, so we have to find each YP. So we let the LDY1 equal to the first arc x, and then we find the y1, and then same for the second arc x, so we find the y2, and the YP will be the sum of y1 plus and y2. And then the fourth method is where we have the trigonometry, where the arc x is trigonometry. Here where the arc x is k, the constant, and sine ax or k cos ax. So where the LD is even derivative and a is here, a here is not the factor of LM equal to 0, so we can inspect the YP equal to a constant sine ax or YP equal to a cos ax. So let me take a look at one example. So here the example is solve the second derivative plus a square and y equal to cos bx. So the first thing that we need to do is we solve the auxiliary equation. From the equation, so we can the auxiliary equation is m square plus a square equal to 0. So first one is we solve the auxiliary equation by using this formula, and then we will have the m equal to plus minus ai. This is the root of our auxiliary equation. And then we note that here is the complex root. So when here is complex root, and then we note that when it's complex root, we can find the complementary solution, which is yc, which we use equal to c1 e power of lambda t cos mu t plus c2 e power of lambda t sin mu t, where the auxiliary where the root is complex root. So from our root, so we find the yc. So here our lambda is 0 and our mu is equal to a. So we just substitute in this. So we get the yc equal to c1 e power 0 x cos our mu is at plus c2 e power 0 x, and then our sine ax. And then here we note that e power of 0 is equal to 1, so we can cancel f, so this is 1 and this is equal to 1, so we simplify our yc, so we get yc equal to c1 cos a, sorry, yeah, he is ax plus c2 sine ax. So now we get our yc. So after we get our yc, so we can proceed to find our yp. So now the third step is we find our yp, which is particular solution. Noted here that from the our equation is content of a and b, where a and b is constant. So we need to consider two cases here to find the yp. So the first case is when the a not equal to b. So if a not equal to b, we get our equation is will be d square plus y, here is b equal to cos x, because a is not equal to b. So from this we refer back to the inspection method that we have discussed first, and then we find which one is same like our question. So here we got trigonometry. Our RN is trigonometry. So trigonometry is same like the method number 4. So we can use but the condition is when a is not the factor of Lm or equal to 0 and Ld is mass derivative, even derivative. So we check here. So the second derivative is even, and our root is plus minus b, so not equal to the root of m. So we can proceed with the inspection method number 4. So here we use the inspection method number 4. So we can use the from the inspection method number 4, our yp will be a here is cos bx. So this is our yp. So we differentiate our yp respect to first and second derivative. So after we differentiate the first one, we'll get the minus ab sine bx. The second derivative, we will get negative ab square and then cos bx. So after we get the derivative of our yp, so we substitute into this equation. Substitute into the first equation, this one. Substitute into 1. So we substitute into 1. So after substitute yp plus yp equal to cos bx. So we substitute this yp and second derivative of yp into the equation here, and then we solve it, and we will get the value of a equal to 1 over a square minus b square. So here we get the value of a. So to find the yp, we just substitute the value of a into our yp here. So we get our yp is equal to a, where is 1 over a square minus b square times with cos bx. So here our yp is equal to cos bx over a square minus b square. Here is a, not 9. A square minus b square. So we already get the yp for the case 1 where a not equal to b. So we can find the solution for the case 1 where the solution is equal to yc plus yp. So we just substitute our yc just now. This one is our yc, so we just substitute here. Our yc is equal to c1 cos ax plus c2 sin ax. And then it's yc, and then we plus this yp, where yp is our yp is cos bx over by cos bx over a square minus b square. So here we get the solution for the our first case where a is not equal to b. So now we proceed to the second case. We proceed to the second case where a is equal to b. So when a is equal to b, our equation will be d square, here is d square plus a square y equal to cos bx. Now take that the question is cos bx, but when a equal to b, so we just substitute b with a, and then we get this equation. And then now we cannot use the inspection because here is the root of m prime. The root of this one is equal to the root of m, where is plus minus ai. So to explain this, I can explain that actually this one is we get from where c1e lambda x cos mu t plus c2 e power lambda t sin mu t. This one we get from this one, but noted that this one only got cos because here after we solve, we will note that one of the constant will be 0. So if here be 0, so here is only got this, and then this one is constant. C is constant, and then here is lambda is equal to 0. If lambda is equal to 0, so here will be 1. So from here we note that our m prime, which is the root of this, is equal to plus minus, because the lambda is equal to 0, and then plus minus mu, which is our mu is ai. So the root of this one is equal to the root of m, which is the original equation. So we cannot proceed with the inspection. So we have to use the undeterminate coefficient. So we proceed to find the yp with the undeterminate coefficient, where we get the yp equal to x cos ax. Here is a cos ax plus b sin ax. But then we check here, there is an overlap between the yp, this one, with our this one with our yc. So noted that our yc is this one. So we note here that there is an overlap, this one yp with our yc. So we need to modify our yp. So we time our yp with this one. We multiply our yp with x. So we will get our new YP is AX cos AX plus BX sin AX. So here we get our new YP. So we check whether it overlap with our YC. So noted that here no overlapping between our new YP and YC. So we can proceed with our new YP, and then we differentiate our YP to the first derivative. So we get here A cos AX minus AXA sin AX plus B sin AX plus BXA cos AX, and then proceed. You move to the second derivative. Here is second derivative of our YP. So we get minus 2 AA sin AX minus AXA square cos AX, so plus 2BA, here is plus 2BA cos AX minus BXA square sin AX, sorry, okay, sin AX. Here we get the second derivative of our YP. So we just substitute the YP and the second derivative of our YP into the equation here. We just substitute into the equation. So substitute d square. Here actually is YP, and then we just substitute into this equation. Here is A equal to cos AX. So we just substitute YP and the second derivative of YP and YP into this equation, and then we will get minus 2A sin AX plus with 2BA cos AX equal to cos AX equal to log AX. So we just compare the left side with the right side. So we get this one. Then when we compare this one, we will get the equation where minus 2AA equal to 0, and then the second is 2BA equal to 1. So we solve these two, then we get A equal to 0 and B equal to 1 over 2A. So we get the value of A and B. So we just substitute to find the YP. We just substitute the value of A and B into the YP. This one, the YP. So we will get our YP. Our A is already 0, so project to the B is our YP will be 1 over 2A sin A. Here got X, yeah, X, then equal to X over A. So we get our YP for the second case. So we to find the solution, so we just substitute our YC and YP. So our YC is 1 C1 cos AX, right? C1 cos AX plus C2 sin AX, and then we plus this our YP. So plus our YP is X over 2A sin AX. So here we get the solution for the second case already. So that was from me. Thank you.